Hey, my name is Peter Lavin of Trinity College Dublin, and this is a presentation of use case number 3 from the Manticore project. In this use case, OpenNaaS software from the Manticore project is used to connect a number of components of a distributed cloud installation. These components are connected using a virtual network created by that software. For this use case, StrataSlab Cloud software is used. Firstly, we need to look a little at the different parts of the StrataSlab Cloud installation. The front-end machine acts as a user interface for both users and cloud administrators, for stopping and monitoring instances of virtual machines, adding new hosts, and so on. There are always one or more host machines, each of which has network connectivity to the front-end machine. A persistent disk machine server provides the storage space, effectively the disk drives, for the VMs which run in the hosts. VMs access their allocated disk storage using iSCSI over the network. A marketplace machine stores and serves up user-created images for use when running VMs. When required for a VM, an image is downloaded to the pdisk machine. When a VM is to be started, the sequence is as follows. From the front-end machine, the user requests that a VM instance is to be created. The required image is downloaded from the marketplace to the pdisk server. A storage volume for the VM is created on the pdisk server to where the downloaded image is copied. The VM is then booted on one of the available host machines. During the boot process, the volume created on the pdisk server is mounted on the host and acts as its disk storage. The network connection from the host to the front-end machine is used to access this storage. In the configuration shown here, all the components of the cloud installation are located on the same premises. That is to say, they are all located in Trinity College Dublin, or TCD as it's called in the slides. Now consider if we need to add another host. In this use case, this additional host is in a different location. It is located in a commercial data center owned by HENet, which is about 20 kilometers away from Trinity College. It is also completely outside the TCD network and firewall. This use case aims to use OpenNaaS to connect a remote machine to the front-end machine so that it can be used as a StrataSlab host. For this connection, an OpenNaaS created virtual network will be used. Prior to the host being added, it must be accessible using, for example, a public IP address. For this use case, it is required that the remote host appear in a private network address space. That is to say, it will have a private IP address space which is in the same address range as the private address on the front-end machine. Both the front-end and the remote machines will have a private IP address in the 10.53 range. Using the OpenNaaS network will allow the remote host to appear to the front-end machine, that is, in this type of address space. The scenario for this use case is as follows. Firstly, the cloud software is installed and the locally available host is added and tested. This part of the work won't be described here. Next up, the required virtual network is created to connect the remote machine to the front-end machine. Following that, the remote host or machine is added to the cloud installation. This involves running a number of StrataSlab commands. These are executed over SSH over the now created OpenNaaS network. On successfully adding the remote host, a VM can then be started in that host. So we will look at how to create the virtual network using OpenNaaS. This is a diagram of the completed network. It can be seen that the network consists of a number of components. Firstly, OpenNaaS was installed on the front-end machine. Then the network was created by carrying out a number of steps using the command line operations in OpenNaaS. we will demonstrate some of the important commands here. The front-end machine needs to connect to a physical router. 3 operations are needed to create a resource in the OpenNaaS software. Then connect or assign it to an actual physical router, the router in HEAnet in this case. This is done in the first command here. In the second command here, the path to a public key is used to allow SSH access to that router. Finally, within OpenNaaS, the resource is started. This is shown in the third command here. Subinterfaces are now created in the router resource created. These are needed later for a virtual router which will be started next. Within this physical router, a virtual or logical router is started. The 2 subinterfaces are added to that logical router. Next, IP addresses are assigned to these. One OpenNaaS command is needed to add an IP address to each subinterface. Note here that the IP addresses used are private addresses, and the addresses to be used can be decided by the user. Next, GRE tunnels are created, represented here by the double red lines in this slide. These connect both the front-end machine and the remote machine to the logical router. There are a number of different types of tunnels which could be used for this, but GRE was chosen because it is compatible with the operating systems of both the front-end and the router used. This slide shows where the required network fits into the StratusLab installation. Note that where the GRE tunnel connects the front-end machine to the virtual router, they pass through the TCD border routers and firewalls. With the front end now connected to the remote machine, it is now possible to add that machine to the StratusLab cloud installation as a host which can be used to run VMs. This was done and worked successfully. We will now demonstrate starting a VM in the cloud installation. At this point, the virtual network is in place and the hosts are added and available for use. So to demonstrate running a VM in the host which is connected using the virtual network, we go to the command line interface of the front-end machine. As user1admin, which is a cloud admin account, we will list the available hosts in the cloud installation using the command onehostlist. We see here that there are 2 hosts available. Number 17 is the local host named cagnode44, and number 18 is the remote host using its IP address as its host name. We want to disable the local host and thereby force the cloud software to use the remote host, which is the one using the OpenNaaS network. We do this by running the command onehost disable 17. When we run oneHostList again, we see that host number 17, which is the local host, is now disabled. On the front-end machine, as an ordinary cloud user, we can watch and monitor the status of existing VMs and the progress of new VMs as they start. We do this by using the command stratusdescribe instance. We use a 1-second watch for this to be able to see changes as they happen. We see here that there's one existing VM which is in the local host and was started earlier. In another terminal, the VM is started by running the command stratus run instance. We see this command here and some other configuration information and a string which refers to the VM image to be used. We run that command and we see that the VM has now started to run. We can now watch as it starts in the remote host. And we can now see that the VM is successfully running in the remote host. Adding further remote hosts can be done by creating additional subinterfaces on the logical router, and then creating another GRE tunnel from that subinterface to the new host or machine. The part of the network between the cloud front end and the logical router remains unchanged. This configuration was tested using a VM in HEANet and worked successfully. So to summarize the achievements of this use case, the front-end machine of the cloud installation was successfully connected to a remote machine using an OpenNaaS Virtual Network. This was the main objective of the use case. The remote machine was successfully added to the cloud installation using standard StrataSlab commands. Both the local host and remote host were then used to run VMs, one in each machine. This use case used routers which were located outside of the TCD infrastructure. However, using GRE tunneling, it was possible to exploit OpenNaaS using a remote router. This step offers one solution to what may be called the last mile problem. While it may be possible to create a network of several virtual routers spanning several international boundaries, the tunneling technique used in this use case connects such a network to computers outside of the in-RAN environment, including computers behind institutional firewalls such as those found in TCD. This concludes this presentation.